Hello students, in this video we're going to be talking about inverse variation. Inverse variation has the equation y equals k over x, where k is equal to yx. If I wanted to identify from a table, we're going to make an example here. Our example is going to be y equals 60 divided by x, where our k is 60. Our constant is 60. Let's go ahead and fill in some numbers for our table. 1. 60 divided by 1 is 60. 2. 60 divided by 2 is 30. 3. 60 divided by 3 is 20. And 4. 60 divided by 4 is 15. So you can see my graph actually goes down as my x's go up. And it goes down proportionally. So from left to right, it's going down. Okay? This inverse variation is going down. The proportion you can use is y times x equals y times x, where you set the old information equal to the new information. Okay? So let's take a look at a straightforward example. If y varies inversely with x, x is 10, y is 50 is our old information. Find x when y is 200 is our new information. So we're going to use the proportion x times y equals x times y because it's inverse variation. So we set up as 10 times 50 equals 200 times y. And this time in my setup, I do not need to cross multiply. I just multiply the same side. 10 times 50 is 500 equals 200y. Then I get out my calculator. 500 divided by 200 is 2.5. So my y is 2.5. All right, let's do another one, slightly more complicated, real world. The volume of a gas varies inversely as its pressure. If the volume is 240 centimeters with 30 kilograms per centimeter squared of pressure, what is the pressure when the volume is 160? Okay, it seems really complicated, but we're going to set up the same way. We're going to say volume times pressure equals volume times pressure for the old equal to the new. So the old is always written first. The volume of 240 and 30. So we're going to say that 240 times 30, that's my old information, equals, well, in my new information I have a volume, but I do not have a pressure. So I'm going to say 160 P. So then I just take out my calculator again. 240 times 30. Then divide that by 160. 45. So my pressure is 45. Then 45 what? Gallons? Miles? Pressure is, you look back up here in the problem, and pressure is defined as kilograms per centimeter squared. So that's how I end my problem. Kilograms per centimeters squared. And that's my pressure. Okay, not too hard of a problem there. All right, let's do the next one. The length of a violin string varies inversely as the frequency. So basically, the shorter the string, the higher the frequency, and the longer the string, the lower the frequency. So let's go ahead and set up our proportion. Let's call length L times frequency, F, equals L, length, times frequency, F. So that's how you set up inverse variation. Has the keyword inverse. And the old information is 14 and 450. So we say that 14 times 450 equals, what do we have in our new information? Our new information, we had the length. So 12 times, we don't have the frequency, F. So I don't know what this is, so I'm going to take out my calculator. 14 times 450 divided by 12. 525. So my frequency is 525. Again, 525 what? Miles, inches, centimeters? Well, frequency is measured in cycles per second. So that's how I answer my question. 525 cycles per second. Okay, and the last thing I need to mention is the same thing as before. I'm going to show you how you tell this is direct variation from a table. If I have a table and I want to see if it's direct variation or inverse variation, sorry, I'm just going to multiply every x times y is the same. So let's check it out. 1 times 60 is 60. 2 times 30 is 60. So it's all going to be 60. 3 times 20 is also 60. And 4 times 15, believe it or not, is 60. So how do I tell from a table whether there's inverse variation? I multiply the x's and y's, and if they turn out to be the same constant, then it's inverse variation. Whereas with direct variation, I divided y by x and got the same number every time. So that's how you tell the two apart from each other. That ends our video on inverse variation.